Example 1, National Forest deer population in danger. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? Why does it matter if the deer population is not constant in a certain area of the national forest? So based on our classroom conversations, a couple of ideas have always came up. And one of those is that the land could be over or underworked, meaning animals could eat more of the grass and plants in one area, or they could not eat another area and it could overgrow, and that it could also disrupt the food chain. All right, our next question. What is the population density of deer per square mile? When we talk about density, we're talking about how much there is of somebody. Towns use population density to show how many people live in a certain area of a town. So when we find the number of deer per 1 square mile, what is this called? And our key thing to look at it here is per 1 square mile. We've talked about that. Per 1 means that we're finding the unit rate. Now we also have to start getting used to this unit rate also being called the constant of proportionality. These things mean almost the same thing. Alright, so our next task says to use a table to organize your numbers to find, this should be deer, it's a typo on my part, sorry, deer per square mile for each area of the forest. Alright, so let's start a table here. Ooh, that got, sorry, I didn't mean for that to get out of focus. Okay, so we're going to make a table here. So we're going to say number of deer. Let's go ahead and put our square miles. We'll write out the ratio, and then we'll turn that into our unit rate. Let's see if I can spell, or our K value. Alright, so we had 3 different areas. So the first area, second area, and third area. Alright, so based on what we had back in the problem, so in our first area we had 144 deer in a 16 square mile area. Then we had 117 deer in a 13 square mile area. And then lastly, 216 deer in a 24 square mile area. Alright, so we're going to write our ratio of deer per square mile. So 144 to 16, 117 to 13, and 216 to 24. Now to find that unit rate, we divide. So if we take 144 divided by 16, we get 9. 117 divided by 13 is 9. And 216 divided by 24 is 9. Alright, our next question. What is the constant of proportionality for this problem? So our K value is equal to that unit rate, which we found in our table was 9. So our constant in this problem is 9. Explain the meaning of the constant of proportionality in this problem. This means that there are 9 deer per square mile. So if we think about if those conservationists need to be worried, the answer would be no, because all of the different areas they counted came out to be the same. All right, use the unit rate of deer per square mile, or y divided by x, to determine how many deer there are for every 207 square miles. All right, so this one we're going to use some equations to help. Now, in one of our previous lessons, we had talked about writing our equation and using the form y equals k times x. So we're going to talk a little bit about that here. All right, so when we talk about this y divided by x, we're really talking about the deer per square mile. So when we have a y value, it's going to represent the deer, and when we have an x value, it's going to represent the square miles. Our k value is our constant of proportionality. So when we make our equation, and this is one thing we need to make sure we remember, the form is y equals k times x. Y equals k times x. If we think about that, if we take our bottom number times our constant, we end up with that y number. Because we were dividing this way, we work backwards and we multiply. All right, so for this problem, I'm going to write what it means. So my y is deer. So deer equals our constant times our x, which is square mile. All right, now we know that we are solving for how many deer there are. And we know that our k value is 9. And we're timesing that by our square miles, which was 207. So when we multiply this, we get that the number of deer is equal to 1,863 square, or number of deer in our 207 square miles. All right, so this one's kind of going the opposite direction. Find the unit rate to determine the number of square miles in which you would find 486 deer. So again, we're going to use that same formula, y equals k times x. Remember, this is our deer and our square mile, and we know that our k value is 9. So we know 486 deer. So if we look back at our ratio, our y is the deer. So we're going to replace this with the 486 times 9 times x. Now when we solve these equations, we haven't done much of this yet, but that's okay because we're going to learn by doing. We multiply by the reciprocal. So a reciprocal is if we have a number such as 9, so we're going to make a side note here. Side note. Oops. If we have 9 over 1, the reciprocal would be this flip, so it would be 1 over 9. So we're going to multiply by the reciprocal, and what we do to one side, we have to do to the other so that it stays equal. Think like a balance beam. We've got to keep everything equal. All right, so when we multiply this, multiply fractions, multiply straight across the top, we get 486 over 9 equals 9x over 9. All right, so we can divide this out right here. And when we divide 486 by 9, we get 36. 9 divided by 9 becomes a 1. I like to write over that those become a 1, and we're left with 1x. So it would be 36 square miles.